Today's lesson is acids and bases according to Bronsted-Lowry concept. In this lesson, we are going to learn Introduction to Bronsted-Lowry concept, Scientist Bronsted, Scientist Lowry, and finally Bronsted-Lowry acids and bases. So let's begin. The first point is Introduction to Bronsted-Lowry concept. Basically, there are two reasons for which Bronsted-Lowry concept is introduced in acid-base concept. Let's see the reasons. The first reason is hydrogen-containing compound, hydrogen chloride gas, is a kind of Arrhenius acid because it can produce protons in presence of water. Again, hydroxide compound, sodium hydroxide, is a kind of base, Arrhenius base, because it can produce hydroxide ions in presence of water. Number 2 is ammonia having no OH group. Nevertheless, this is basic in nature. Ammonia, no OH group, nevertheless it is basic in nature. So, Arrhenius concept is applicable only in aqueous solution, and the basic property of ammonia cannot be explained with the Arrhenius concept, or Arrhenius concept cannot explain the basic property of ammonia. Considering these limitations, scientist Bronsted and scientist Lowry proposed a more general acid-base concept independently in the year 1923, which is known as Bronsted-Lowry acid-base concept. Now let's see a short biography of scientist Bronsted and scientist Lowry. Scientist Bronsted. His full name was Johannes Nicholas Bronsted. He was a Danish physical chemist. He was born on 22nd February in 1879 in Varde of Denmark. He died on 17 December 1947 in Copenhagen of Denmark. His span of life was 68 years approximately, and he was known for basically Bronsted-Lowry acid-base theory. Now let's see a short biography of scientist Lowry. His full name was Thomas Martin Lowry. He was an English physical chemist. He was born on 26 October in 1847 in Low Moor of United Kingdom. He died on 2nd November in 1936 in Cambridge of United Kingdom. His span of life was 62 years approximately. He was known for Bronsted-Lowry acid-base theory. Let's see the next point. Now the point is Bronsted-Lowry acids and bases. First of all, let's see which compounds are Bronsted acids and which are Bronsted bases and why. That means definition of Bronsted acids and bases. First of all, Bronsted acids: hydrochloric acid, nitric acid, sulfuric acid, bisulfate ion, phosphoric acid, dihydrogen phosphate, water, etc. These are Bronsted-Lowry acids, and Bronsted-Lowry bases are water, ammonia, hydroxide ion, etc. So these compounds are Bronsted-Lowry acids, and these compounds are Bronsted-Lowry bases. The definition of Bronsted-Lowry acid is: the hydrogen containing compounds that can produce protons are called Bronsted-Lowry acids, and Bronsted-Lowry bases are the compounds that can accept the proton which is produced from acids are called Bronsted-Lowry bases. That means simply Bronsted-Lowry acids release protons and Bronsted-Lowry bases accept that protons. So Bronsted-Lowry acids are proton donors and Bronsted-Lowry bases are proton acceptors. Now let's see the acids and bases through proton transfer reactions. Bronsted-Lowry acids are proton donors and bases are proton acceptors. Now let's see the reaction, because Bronsted-Lowry acids can function as acids only in presence of bases. Without bases, Bronsted-Lowry acids cannot function as acids. First of all, let's write Bronsted-Lowry acid, that is hydrochloric acid, and Bronsted-Lowry base is water. Here, this compound donates proton and water accepts that proton, and after that it changes to chloride ion, and this water changes to a hydronium ion. So its name is hydronium ion. So here this is proton donor and this is proton acceptor. So in this reaction, this is Bronsted-Lowry acid, proton donor, and this is Bronsted-Lowry base, proton acceptor. Let's see another proton transfer reaction, that is sulfuric acid and water. In this proton transfer reaction, sulfuric acid donates proton and water accepts that proton, and after donating proton it becomes bisulfate ion and water becomes hydronium ion. The name of this ion is bisulfate ion. So in this proton transfer reaction, sulfuric acid donates proton and water accepts that proton. So according to Bronsted-Lowry concept, this is an acid and water is a base. Now the proton transfer reaction is the reaction between nitric acid and water. Here nitric acid donates proton and water accepts that proton. After donating proton, this nitric acid becomes nitrate ion and water becomes a hydronium ion. So in this case we see nitric acid donates proton, that means this is proton donor, that is acid, and water is proton acceptor, that means water is a base. So nitric acid is an acid, Bronsted Lowry acid, and water is a Bronsted Lowry base. Now the proton transfer reaction between phosphoric acid and water. H3PO4, this is phosphoric acid, this is water. Here phosphoric acid donates proton and water accepts that proton. After donating proton, phosphoric acid becomes dihydrogen phosphate ion, and this is a hydronium ion. Its name is dihydrogen phosphate ion. Here this compound is donating proton, so this is Bronsted Lowry acid, and water is accepting that proton, so this is Bronsted Lowry base. Now the proton transfer reaction is, suppose a salt, acidic salt, sodium dihydrogen phosphate, if it is dissolved in water, then we get sodium ion and dihydrogen phosphate ion. Now this dihydrogen phosphate ion and water undergoes proton transfer reaction in this way, that is dihydrogen phosphate ion plus water. Here it donates another proton and water accepts that proton. After donating proton, it becomes monohydrogen phosphate ion and water becomes hydronium ion. Its name is monohydrogen phosphate ion. So in this reaction we see this ion, dihydrogen phosphate ion, donates proton. So here this is Bronsted Lowry acid and water accepts that proton, so this is Bronsted Lowry base. So Bronsted Lowry acids are maybe neutral compounds or maybe negatively charged ions. Let's see another proton transfer reaction. Now the proton transfer reaction is between HCl and ammonia. In this reaction, HCl donates proton and ammonia accepts that proton. After donating proton, it becomes chloride ion, and after accepting proton, ammonia becomes ammonium ion. So in this reaction, this is proton donor, so this is Bronsted Lowry acid, and ammonia is proton acceptor, so ammonia is a kind of Bronsted Lowry base. Now the proton transfer reaction between HCl and hydroxide ion. Hydroxide ion, that means when sodium hydroxide is added to water, then it becomes plus and minus. That means sodium hydroxide ionized to sodium plus and hydroxide minus. When in this reaction HCl is added, then a proton transfer reaction happens. Now let's see how proton transfer reaction happens. HCl and hydroxide ion. HCl donates protons and hydroxide ion accept that proton. After donating proton, it becomes minus, and after accepting proton, hydroxide ion becomes water. So in this reaction, HCl is proton donor, that means Bronsted-Lowry acid, and hydroxide ion is proton acceptor, that means hydroxide ion is a kind of Bronsted-Lowry base. Now let's recap the Bronsted-Lowry acids and base again. Bronsted-Lowry acids are hydrochloric acid, sulfuric acid, etc. And Bronsted-Lowry bases are water, ammonia, hydroxide ion, etc. That means Bronsted-Lowry acids must contain hydrogen element, and Bronsted-Lowry bases must contain lone pair of electrons. Here one pair of electrons, in this case one pair of electrons. So Bronsted-Lowry acids must contain hydrogen element, and Bronsted-Lowry bases must contain lone pair of electrons. So Bronsted-Lowry acids are proton donors and Bronsted-Lowry bases are proton acceptors. Bronsted-Lowry acids can function as acids only in presence of bases. Without bases, Bronsted-Lowry acids cannot function as acids, and vice versa. Now today, thank you very much.